In this video, I will discuss the topic truth table and validity of arguments. That is, I will discuss how to determine the validity of an argument in symbolic logic using the truth table method. It must be noted that there are two basic methods in determining the validity of an argument in symbolic logic, namely the truth table and partial truth table methods. But again, in this video, I will only discuss the truth table method. I will discuss the partial truth table method in a separate video. Now, how do we know whether an argument is valid or invalid? On the one hand, a truth-functionally valid argument form is an argument that is composed of propositions that have truth-functional forms, such that it is impossible for its premises to be all true and its conclusion false. In other words, an argument is valid if it does not contain the form all true premises and false conclusion. On the other hand, a truth-functionally invalid argument form is an argument that is composed of propositions that have truth-functional forms, such that it is possible for its premises to be all true and its conclusion false. In other words, an argument is invalid if all of its premises are true and its conclusion false. Let's consider this example. If the squatters settle here, then the cattleman will be angry and that there will be a fight for water rights. The squatters are going to settle here. Therefore, there will be a fight for water rights. S, C, F. Now, how do we determine the validity of this argument? Before we can apply the truth table method in determining the validity of this argument, we need to symbolize the argument first. After symbolizing the argument, we will construct a truth table for the argument, and then apply the rule in determining the validity of arguments in symbolic logic. But how do we symbolize this argument? By the way, in case one does not know how to symbolize arguments in symbolic logic, please refer to our previous discussion about symbolizing propositions in symbolic logic. You can find the link on the upper right corner on your screen. Now, in symbolizing arguments in symbolic logic, we just need to apply the techniques that we employed in symbolizing propositions. Hence, we symbolize arguments in symbolic logic proposition by proposition or sentence by sentence. If we look back at the argument, the first proposition is, if the squatters settle here, then the cattleman will be angry and that there will be a fight for water rights. And then we see the constants S, C, and F at the end of the argument. And if we recall my discussion on symbolizing propositions, we learned that the variables or constants provided after the proposition represent the propositions in the entire proposition respectively. Hence, the constant S stands for the squatters settle here, C for the cattleman will be angry, and F for there will be a fight for water rights. Thus, the first proposition, if the squatters settle here, then the cattleman will be angry and that there will be a fight for water rights, is symbolized as follows. S, then C, and F. The next proposition in this argument says, the squatters are going to settle here. As we notice, this proposition is just a repeat of the proposition in the previous statement, and this proposition is symbolized by the constant S. Hence, the second proposition, the squatters are going to settle here, is symbolized as S. Finally, the third and last proposition is obviously the conclusion because of the signifier therefore. This proposition is also a repeat of the proposition in the first sentence, which is symbolized by the constant F. Hence, the conclusion, therefore, there will be a fight for water rights, is symbolized as F. At the end of it all, the argument, if the squatters settle here, then the cattleman will be angry and that there will be a fight for water rights. The squatters are going to settle here. Therefore, there will be a fight for water rights. SCF is symbolized as follows. S, then C and F. S, therefore, F. Please note that in the symbolized form of the argument, S, then C, and F is the first premise. S is the second premise, and F is the conclusion. Now, how do we construct a truth table for this argument? Well, first, we need to construct a truth table that contains columns for the variables or constants and columns for the premises and the conclusion. In order to do this, we will use the formula 2 raised to the power n, where 2 is constant and n is a variable. The n in the formula 2 raised to the power of n represents the number of variables or constants used in the argument. And so, since the sample argument contains 3 constants, namely S, C, and F, then the formula now reads 2 raised to the power of 3. So 2 raised to the power of 3 is equal to 8. This means that we need to construct a truth table that contains 8 rows. But first, we have to draw columns for the constants in the premises and the conclusion, which will look like this. After drawing the columns for the constants in the premises and the conclusion, we will now draw 8 rows. With this, the truth table will now look like this. And now that we have constructed the truth table that contains the columns for the constants in the premises and conclusion, let us provide the truth values of the variables S, C, and F. We need to do this because the truth values of the premises and the conclusion will be based on the truth values of the variables or constants. But how do we do this? Well, first, it must be noted that the product 8 also represents 4 true values and 4 false values for the variable or constant, which is S in this example. And the rule here is that we write the true values first and then the false values. So the truth table will now look like this. For the next column, that is column C, we need to divide the 4 true and false values by 2. Thus, we will have 2 true values and 2 false values. The rule is, we will write 2 true values first and then 2 false values. For the remaining rows, we will write 2 true values and 2 false values alternately. So the truth table will now look like this. Now for the next column, that is column F, we need to divide the 2 true and false values by 2. Thus, we will have one true and one false value. And the rule is, we will write one true value first and then one false value. Now the truth table will now look like this. Now for the remaining rows, we will write one true value and one false value alternately. So the truth table will finally look like this. Since we already have the truth values of the constants S, C, and F, we can now determine the truth values of the premises and the conclusion. Please note that we need to provide the truth values of all the premises and the conclusion before we can apply the rule in determining the validity of an argument. So, let's provide the truth values of the premise. The first premise is S, then C, and F. As we can see, the first premise is a conditional proposition whose consequent is a conjunction. We also need to remember that in determining the truth value of this premise, we need to apply the rules in conditional and conjunctive propositions. Well, if you do not know yet the rules in conditional propositions and conjunctive statements, check out our separate videos on these topics. Links are provided below. Alright, let's proceed. Now, before we can apply the rule in conditional proposition in the premise S, then C, and F, we need to simplify first the consequent C and F. This can be done by determining its truth value using the rule in conjunction. Since the rule in conjunction says, a conjunction is true if both conjuncts are true, then the truth table will now partially look like this. Please note that in this truth table, I temporarily removed the column for S to avoid confusion. That is, in order to show that we are just using the values for columns C and F. Since we already have simplified C and F, then we can now proceed to determining the final truth values of the first premise, S, then C, and F. Now, the truth table will look like this. Please note that the final truth values of the first premise, S, then C, and F, are the ones in bold red. Let me illustrate how I arrived at those values. But let me just illustrate the first two rows. So, in the first row, S is true, C is true, and F is true. So, S, then C, and F is true. Now, in the second row, S is true, C is true, and F is false. So, S, then C, and F is false. For the truth values of the second premise, which is S, we just need to copy the truth values of S in the first column. This is obviously because the second premise is a simple proposition. So, the truth table will now look like this. And for the truth values of the conclusion, which is F, we just need to copy the truth values of F in the third column. And this is obviously because the conclusion is a simple proposition. Now the truth table will look like this. As we can see, the truth table is now complete. So we may now apply the rules in determining the validity of arguments in symbolic logic. But before we proceed to that, let us remove the columns for the variables in order to avoid confusion. It must be remembered that the rule talks about the premises and the conclusion only, and so we may now drop the variables. But of course, as we can see, the columns for the variables or constants are needed only in determining the truth values of the premises and the conclusion. And so, the truth table of the argument will finally look like this. Now, if we recall, the rule in determining the validity of an argument in symbolic logic says that an argument is valid if it does not contain the form all true premises and false conclusion. And an argument is invalid if all of its premises are true and its conclusion false. Please note that in applying the rule, we need to consider all rows in the truth table. So the easiest and most convenient way to do it is to look for an invalid form in each row. That is, a row that contains all true premises and a false conclusion. Thus, if we cannot find one, then the argument is obviously valid. If we look at the final truth table of the sample argument, we cannot find at least one row that contains the form all true premises and a false conclusion. Therefore, at the end of the day, the argument, if the squatters settle here, then the cattleman will be angry and that there will be a fight for water rights. The squatters are going to settle here, therefore there will be a fight for water rights, is absolutely valid. Finally, let me give an example of an invalid argument so we can fully understand why the first example is valid. Consider this example. If Marco had been a poor businessman, then he would have to undertake extensive lecture hours. He did undertake extensive lecture hours. Hence, he must be a poor businessman. P, Q. I don't think I need to explain again here why we have come up with this truth table. The discussion earlier is enough for us to know how to construct a truth table. Now, although not necessary, but let's remove the columns for the variables in the truth table to avoid confusion. So the truth table will now look like this. If we recall, the rule in determining the validity of an argument in symbolic logic says that an argument is valid if it does not contain the form all true premises and false conclusion. And an argument is invalid if all of its premises are true and its conclusion false. Please note that in applying the rule, we need to consider all rows in the truth table. And again, the easiest and most convenient way to do it is to look for an invalid form in each row. That is, a row that contains all true premises and a false conclusion. Thus, if we cannot find one, then the argument is obviously valid. And so, if we look at the final truth table of the second sample argument, we can, indeed, find one row that contains the form all true premises and a false conclusion. Thus, at the end of the day, the argument, if Marco had been a poor businessman, then he would have had to undertake extensive lecture hours. He did undertake extensive lecture hours, hence he must be a poor businessman. PQ is absolutely invalid. That's it for now. Thanks for visiting us today for another whiteboard discussion here at PHILO-notes. Full transcript of this video is available at PHILO-notes.com. And to keep you updated of our newest videos, simply click here and subscribe, and tap the bell for notifications. Thanks! Take care!